Hey, I'm going to do the number 6 through 10 on this vector worksheet 1. I just broke this up in 2 videos because it was broken up for you into 2 assignments, so why not? Alright, so how about number 6? What do we got? Determine the magnitude and direction of the resultant. Sometimes when you add 2 vectors together, that instead of calling it the sum, you call the thing, like the answer, you call it the resultant vector. That's all that means. It's fancy vocabulary. So we just want to add A and B together. It's the same thing we were doing in number 5. So I've got vector A and B, and I want to break them into their x and y components. So we're doing the north, south, east, west thing again. So the first vector here, A, is 5 magnitude at 20 degrees. So around to the nearest tenth on these. And let's see, that was 20 degrees north of west, so that's toward the north from west. That is in quadrant number 2. So quadrant 2 is negative, positive. I'm going to put signs on both of those just to try to discipline myself to always pay attention to that. And then the other one is magnitude 4 at 60 degrees. So 4 cosine 60, 4 sine 60, 2 and 3.5. And that is in the first quadrant, north of east. I'm going to go ahead and put those on there. It just tells me that I did pay attention to that. I didn't forget to do it. Add them together. Okay, and then for the final move, the magnitude and direction of the answer. The magnitude is our little Pythagorean theorem here. It's a 2, sorry. 2.7 squared, 5.2 squared. The direction is tangent inverse of rise over of y over x. Sometimes I say rise over run because y over x. That's how you do slope. And time to push the buttons. .9 and 62.6 degrees. And that is in quadrant, let's see, what was my answer? Negative, positive. That's in quadrant 2. All right. Not so bad. And that's pretty much as hard as they get, right? And that's all the work that you ever have to do. All right, what's on this next page? A dog searching for a bone. Aw. Walks 100 meters due east. And then 200 meters at an angle 60 degrees north of west. North of west is second quadrant, so that's 200 meters like this way, 60 degrees north of west, and then 150 meters at an angle 30 degrees south of west, so that's like this. That's 150, kind of running out of space here, and they're telling us angles measured from horizontal, which is good. That's what we want. All right, so let's call the different parts of this dog's epic journey leg 1, leg 2, and leg 3. It's a 3-legged dog. So what are the x and y of each one of those? So the first one is 100 meters due east. Due east is like all x, so 100 meters due east is just all x and no y. It's like there's no angle there, right? 200 meters at an angle that is 60 north of west. So I need to do 200 cosine and 200 sine 60. 200 cosine 60, 200 sine 60. There's my x and my y, 100 and 173. And that is north of west, which is in quadrant 2, which is negative, positive. And this was positive and 0, 0. I need to put a sign on that. Okay. And then leg 3, like what's up with this? Can you add 3 of them together? Sure. Just stack them up. And leg 3 is 150 at 30 degrees. So 150 cosine 30 and 150 sine 30. So 130 and 75. What quadrant is that in? That's in the third quadrant. That is south of west. You need a little compass here, right? North, south, east, west. So south, here's west, south of west is down into the third quadrant. And in the third quadrant, both of those would be negative. So the total journey is negative 130. And then that's what? Positive 98. And we want to find the magnitude and direction of the net displacement. So magnitude and direction. Net means sum, right? Total. Magnitude, direction. Magnitude's going to be 130 squared, 98 squared. Direction, tangent inverse y over x. $163, what is this, meters? Yeah, meters. And angles just have units of degrees, right? I mean, for us, I guess you can do it in radians sometimes if you're a fancy calculus person or something. 37 degrees. What quadrant are we in? We are negative positive, so that's quadrant 2. That's over here. That's north of west. All right. Number 8, soccer ball is kicked at an angle 40 degrees above the ground with a speed of 18 meters per second. So imagine the ball is kicked like this at 18 meters per second. So that's its speed in this direction. What are the horizontal and vertical components of the velocity? So that's just asking for these two things. This is really just, I mean, compared to what we just did in 6 and 7, this is like super short, easy problem. All I have to do is the velocity in the x direction, the velocity in the y direction is 18 cosine 40 and 18 sine 40, and that's it. If that seems kind of, I don't know, does that seem pointless to you to do? Well, that's a dangerous question to ask. Like all of this seems pointless to me, Mr. McGrath. Well, come on, that's not fair, I don't think. But if this seems like, in the context of this, if it seems like, why would we just break up this? This is anticipating something we're going to do in Unit 6. Assuming the world has not ended by then we will look at two-dimensional motion, and this will be an important thing that we need to do. So that's all, just to get you to think about, like, it's not just like doggy journeys, it's not just distances that you can break up. You can also do it with velocities. This thing's kicked this way, then that velocity, which points in a certain direction and has a size. We can break that up into its components too. and that'll be important for us later. Three-way tug-of-war takes place with three people pulling on a tire with attached ropes, as shown in the diagram. What's the magnitude and direction of the resultant sum of these forces? Okay, so just break them up, add them up. There's three of them, and they're labeled F1, F2, and F3. So let's see. I'm going to find the X and the Y components of each one. It looks like F1 I don't actually have to break up. That's like all X and no Y. If you're right on like horizontal or vertical, then one of these is going to be 0, and the other is going to be the whole thing, and that's positive. F2, I got 8 to 45 degrees. So 8, 45 degrees. 8 at 45 degrees. Of course, 45 degrees, you're going to get the same. It's a equilateral right triangle? No, equilateral isosceles right triangle. That's the right vocabulary words. I've taught a lot of math classes over the course of my teaching career, but I never ever taught a geometry class. I know about geometry, triangles, whatever, but I never did actually teach it as a class, so there you go. And the last one is 10 cosine 60, 10 sine 60. 5. Did I make both of those? I think I was talking and like just totally spacing out. Those are not both positive. This is in the second quadrant, which is negative positive. Boy, keep your mouth shut. Pay attention, McGrath. That's 5, and this is 8.7, and that's in the third quadrant where everybody is negative. Don't go there if you want to have a good time. So 14, and then, so that's what, 2.3, I think? No, 3.3. Right? Better just make sure. I'm pretty sure. Actually, I'm very sure. But I'm just going to make sure. And then here, that's minus 3. So if we want to find the magnitude and direction, we just need to put them back together, like we've been doing. So the magnitude is this, and the direction is this, and the calculator says this. Cow says moo. I don't know if when you were a kid, or maybe if you have any like younger siblings or cousins or kids you hang out with, there's a Sandra Boynton book. You'd recognize like her style of drawing, of illustrating if you saw it, even if you don't know her books. She's written a lot of books for kids, and one of them is called, what is it called? It might be called Barnyard Dance or something like that. But anyway, it starts out, cow says moo, sheep says ba, 3 singing pigs say la la la. That was my daughter's favorite when she was very little. Cool story, bro. So this is the X and this is the Y. That's positive X, negative Y. That's in the fourth quadrant. And we're not doing north, south, east, west in this problem, so I'm just going to say quadrant 4. All right, last one. A golfer putting on a green puts the ball 5 meters due east on the first putt. 3 putts, so let's call them P1, P2, and putt 3. So if you're putting due east, there's no angle there, so that's all east, which is the X direction. And then on the second putt, 2.1 at an angle of 25 degrees. 2.1 at an angle of 25 degrees. And that is, what was the direction of that? North of east. That's first quadrant, so they're both positive. 1.9 and maybe I'll keep one more decimal place there, and then 0.89. How about that? And those are both positive. Last one is 5 meters due north. So due north, if we're thinking about these directions, due north is that's like the positive y direction. So that is all y and no x. And notice that there's no angle there for you to use, even if you wanted to. And that's half a meter. It's a 3-putt. Not supposed to do that. To get it in 1 or 2. 6.9, 39, and those are both positive, so we want the magnitude and the direction. You never imagined in your wildest dreams how much you would be using the tangent inverse function. How useful that is. Let's clear that out of there. So square root of 6.9 squared plus 1.39 squared. I think I'll just keep the nearest tenth. So 7.0 meters. And here we got tangent inverse, 1.39 over 6.9. It's about 11.4 degrees. And this was a north, south, east, west problem. So when I say that it's in the first quadrant here, that means north of east.